Hello, everyone. This is an example of multiple inheritance and the method resolution order. We're going to look at an example with geometric shapes to demonstrate how MRO works. How can we use super to call on parent classes methods? And when we have multiple inheritance, how we can benefit from using kwargs and how we should pay attention to avoiding name clashes. All right, let's take a look at the code that we have here. We have a few different classes. We have a rectangle class, we have a square class, a triangle, and then a right pyramid class. If we look at the relationship between the classes, we see that the square is inheriting from rectangle, which makes sense because we all know that a square is a special case of a rectangle with 4 equal sides. When we look at the right pyramid, we see that we are inheriting from square and triangle. And if we are like me, a little bit rusty in geometry, we can do a Google search and see that for a right pyramid, we have a square base and also 4 triangular faces. That's the reason why we are inheriting from both square and triangle. All right. If we look at the method resolution order for the right pyramid class, we see that this is the order that Python will follow when searching for method or attributes. We'll start on the right pyramid. If we don't find it there, we'll go to the square class. If we don't find it there, we'll go to the rectangle class, then to the triangle, and finally, Python will look for the method or the attribute in the object class, which is the base class from which all other Python objects inherit from. So far, so good. All right, let's look at the right pyramid and let's look at the dunder init method. We have a base parameter and we have the slant height. The base would be related to the square and the slant height is for the triangle. We are setting those attributes here, and then we have an area method that allows us to calculate the total surface there. And this is the, again, this is the formula that we can find from Google. It's half of the perimeter multiplied by the slant height plus the base area. All right, if we look at the base area, we are using super to call on the parent class method. And this is good practice because we are, first, we are avoiding repetition. And second, we are limiting the places that we need to look for errors or fix. If there was a problem with this area method, then there's only one place that I need to make those modifications, and that will be on the parent class, instead of making that change in the parent and the right pyramid class. The parent class of right pyramid is a square. So what Python will do, it will look for the area method in square, but as we can see here, it's not defined there, so it will go to the rectangle class. And this is where we have the area. All right, let's see. So here I'm creating an object of the right pyramid class. And then if I try to run the area method, we see that we get an attribute error. It says that right pyramid object has no attribute length. And that makes sense because we only have a base attribute and a slant height attribute based on our dunder init method. What we really need to do here is to make sure that we call all the other parent init methods to make sure that we have all the attributes. So let's do that now, and let's modify this base code a little bit. So let's start by calling the square init method. And here I can pass base because that will be the length of the square, and subsequently this will be the length and the width of the rectangle, which is the same. But here I will run into a few problems because we want to eventually call all the different under init methods. We want to go through the square, through the rectangle, and then through the triangle. And we see that we really have different names. And we have different names for the same attributes, basically. We have a length, we have a width, but these two can be, they are the same as the base, really. And then for the triangle, we have the height instead of the slant height. This is where we want to take advantage of using kwargs. And the way we're going to do that is by first creating an empty dictionary. And now what we can do is that since we know that we really need the height and the length, we're going to add those keys, and we are setting those values to be the parameters of the right pyramid object that we see here. All right. And now what we need to do here is make sure that we add or pass that argument. Now we can add a few print statements to show you guys where we are. Let me add that. Print in a rectangle. I can do the same here, even though I need to call it the triangle. That's good. And all right, so far we have super. We are calling square. That makes sense. Square is calling the dunder init method in rectangle, and we should follow the same practice here. We are passing kwargs again, and we are using the double asterisk to make sure that we are passing this dictionary as individual keyword arguments, meaning that in reality what the interpreter will see is something like height equals slant height and length equals base. Okay, we need to make sure that we actually take kwargs the same here. And this step may be confusing here because this one is pretty clear. From square we are going to rectangle, but we know that the rectangle is not inheriting from anywhere else. So rectangle itself doesn't have a parent. But what we are doing is actually following the MRO. So from rectangle we are going to triangle. And we can print to see what extra stuff we have. So let me check. We have, okay, dunder init. Here we need to be, we could be, this will work, but we can be a little bit more explicit here, say that length equals length, and then width equals length. Okay. And now, if we create an object again, we see that first we are going, everything, all of this is happening. Then we are calling the square down underneath. We are passing base. Even though that's an extra keyword argument, we have, and then we are passing the individual keyword arguments. We see that we are in square. Then we go to rectangle. Here we are setting the object's length and object width. We are printing the keyword arguments, and we see that we have a base and a height. Really, this base we are not going to need it anymore, but this was to show how to manage different argument names. And we have the height, which we are going to pass to the triangle class. We are setting the base to the base and the height to the height that we have. And right now, if we try again to do the area method, we see that it's working. That's the reason why we should use kwargs. Now, let's look at the second point. We should avoid name clashes. To calculate the total surface area of a right pyramid, we have two options. We have this formula, or we can look at 4 times the triangle area plus the base area. So let's go ahead and write that and start writing that function. Let's say def area 2. We are passing self, the object, the instance. We have, first we need the base area. We can, again, copy and paste this. We are calling the square, which eventually we'll call the rectangle method. And then we have the triangle area. And here it's where it gets tricky, because we have at least 2 options. One would be to call the super, to call the method using super. But if we do this, and let's go ahead and print the base area and the triangle area, we'll see that, okay, okay, I need to R1 equal, I need to create the object again, the instance. Here we see that both areas are the same, and that doesn't make any sense. What's happening here is that we have a name clash. We're calling the same method. Both of them are the rectangle method. And to make that more explicit, we can call it, rectangle. We can add that print statement. We'll create the instance again. And we see that, in fact, we are, both times we are here. And that makes sense because we are following the method resolution order. We'll go to square, we don't find it there, we go to rectangle. How do we go to triangle? We have 2 options. The first one will be to actually do something like this. We can do rectangle, and we can do self. This means that we start looking above the rectangle class. This is an explicit way of basically saying, okay, start looking at the triangle. And if we get the instance again, we run the area 2 method, we see that it's working now. Let me just change this because actually the numbers, I think that they are giving us the same answer. Yeah. So we see, I mean, rectangle only once, we get the base area 2 times 2, and then we have the area of the triangle, which is 2 times 6 divided by 2, 6. Makes sense. So that's option number 1. Then we have option 2. This may be a simpler option in the way that what we can do is simply call super and call tree area. And what we should do is here, we need to add that method. Tree area. And again, we are looking for, we should get 2 and 6. Fix that. And that's correct too. Basically what we are doing, again, we are looking at the square class. We are looking for tree area. It's not in the square class. We are going to the rectangle class. It's not there. And finally, it's in the triangle class. And the result is correct. This third option, and this is my favorite one, will be to option 3. Call super, call area, but actually call the triangle directly, call the triangle class. And this is much more explicit, much more clear, in my opinion, and also a very short syntax. We're creating the instance again, and if we do the area method, what happened? Oh, shoot, I forgot to pass self. Yes, yes, I need to pass self. Because remember, whenever we are calling a method using a class, we have the class name, we have the method, and we need to pass the instance. Let's do again. And here we have the 3 different options to avoid name clashes. All right, that's all. Feel free to leave any questions in the comments, and I hope this helps you to understand the method resolution order and how it can get tricky with multiple inheritance, but at the end of the day is to make sure that you understand the order and you understand what is the real world relationship between the different classes. All right, see you in the next one. Bye.